we go. So 2 cubed. You guys know what 2 cubed means, right? That means 2 times 2 times 2, which is, Audrey? 8. There we go. All right, so then 2 squared we know is 2 times 2, which is 4, and we know 2 to the first is just 2. What's 2 to the 0? Nope. Nope, good guess.
1.
It's just 1. If I type it in my calculator, 2 to the 0 power is 1. 2 to the negative first power, this is again an exponent. We call this the base is 2, and the exponent is negative 1. If I type in 2 to the negative first, what do you guys get in your calculator? You get a decimal, don't you? What do you get? 0.5. What is 0.5 as a fraction? You math frac that. Not just 1 over 2. And if you type in 2 to the negative second, you get 0.25. Wasn't that just 1 over 4? Okay. So as we go through, 5 cubed, 5 times 5 times 5, you get 125. 5 squared is 5 times 5, or 25, and then 5 to the first is 5. What's 5 to the 0? What's 5 to the 0? What do you get there? Just 1, right? Throw it in your calculator. 5 to the 0 power is 1. 5 to the negative first, I think I got 0.2. Isn't that 0.2? Well, as a fraction, if I math frac that, that's 1 over 5. Okay? And 5 to the negative second is a decimal. I got 0.04. And 0.04 as a fraction is 1 over 25. You guys okay with those? So as we take a look, next one, 10 cubed, 10 times 10 times 10. Morgan, did you get that one? What did you get?
1,000.
1,000, boom. We know 10 squared is 10 times 10, which is a hundo. 10 to the first is just 10. 10 to the 0 power, 1. 10 to the negative first, I got 0.1. What's 0.1 as a fraction? Take a guess. This is 1 over 2, this is 1 over 5, this is 1 over, Colton? 1 over 10, thank you, sir. Sorry, we have that fan on back there. It's hard for me to hear. Plus, I'm old. Okay? Can't hear very well. Over here, I got 0.01, or 10 to the negative second power, and that's 1 over 100. Okay? So there's something that we see over and over and over. First off, it's this guy. This guy right here. What do you guys think you can conclude? Anything raised to a 0 power will always give you what? Just 1, right? So that's pretty important. So I'm going to use a different color here. So I got anything raised to a 0 power is just 1. So even x, some unknown number to the 0 power, is 1. So that's pretty important. And that's what this first property is down here. 0 is an exponent. For every non-zero a to the 0 power, we get 1. And then the negative exponent. This guy right here. I'm a highlighting kind of guy, by the way. If you're new to my class, I like to highlight important stuff. Look at this guy. 2 to the negative first is 1 over 2. 5 to the negative first power is 1 over 5. 10 to the negative first is 1 over 10. So if I have x to the negative first. That's going to be 1 over x. And that's the negative exponent rule. It says for every non-zero a, and if I have an integer n, if I have a to the negative n power, then I'm going to get 1 over a to the n. What I talk about is think of this as over 1, and if it's uptown in the numerator, I shoot it downtown and make it a positive exponent in the denominator. So this is where I talk about uptown, downtown. If it's uptown and it's a negative exponent, shoot it downtown. If it's eventually we'll talk about if it's downtown, we're going to shoot it uptown and see what happens. Okay? So shoot it downtown. All right, so let's put this in action, guys. You have some examples that we want to do. And here we go. We've got a few examples. We're not going to do every single example, but we're going to do quite a bit of these. All right, here we go. So examples, simplify each expression. I got 37 to the 0 power. What's 37 to the 0? What's anything raised to the 0, Damien? It says 1. That's it. There's no work that needs to be shown. Next one, I've got 3 to the negative 4th. Yeah, I could throw that in my calculator or just follow the little rule. If it's uptown and it's negative exponents, shoot it downtown. And now what I get is 1 over 3 to the 4th. We want to simplify that. So it was a negative exponent. It is now down. Make it a positive exponent, but simplify. What's 3 to the 4th? What's 3 times 3 times 3 times 3? What is that? 3 times 3 is 9. Times 3 is what? 27 times 3. What's 27 times 3? The 81. 27 times 3. All right. So the big rule is no negative exponents. We always want to make them positive. So in this case, on number 3, it's downtown. Well, if it's downtown, shoot it uptown. I'm going to bring this guy up. Okay, so I'm going to use a different color here for this 5 so you can see what I'm doing. So that is a green 5. That's on the uptown. These guys were downtown. Now we're going to bring them back up. Make it a positive 2. So it's 5 squared up. And then we simplify. Please excuse my dear Aunt Sally. I got 5 squared. What's 5 squared? What's 5 times 5? 25. And guys, I see a lot of people with the Chromebooks. You don't need your Chromebook out anymore. You can close those. That's kind of the distractor for a lot of you guys. So I know them with my kids. I got an 11-year-old, an 8-year-old. I got a 10-year-old, 8-year-old, and 5-year-old. Man, you put a screen in front of those guys, they can't concentrate. 5 times 25 is, what is that, 125? Easy peasy. All right, any questions there? Yes, ma'am. Oh, man, you're missing the good stuff. Hurry up. Or if you can wait. All right, here we go. We got 4. I got 3 over 6 to the negative first. What do I do? What do you do? Any ideas? Taya, what do we got to do? Yeah, uptown. Uptown, downtown. Here we go. Shoot it uptown. So this 3 stays there. And now I bring the 6 up. And now it's 6 to the first. Positive. 6 to the first is just 6. 6 times 3 is how much? 18. There we go. Good stuff. So far, so good? All right, when I take a look at number 5, a lot of people think this is 1, but this reads the opposite of 4 to the 0 power. So if I read number 5, the idea is I got to do 4 to the 0 first. and then do the opposite of that. So if I cover up this negative, what is 4 to the 0? That's 1, and the opposite of that is negative 1. So there's my answer for that one. You guys good? All right. Let me take a look at this one. I've got 5 to the 0 on the bottom. What's 5 to the 0, Ryan? That's 1. And what's 1 divided by 1? 1. Boom. You guys okay with that? Okay. So that's with the numbers. Now we start introducing with different variables. Okay. The rule is no negative exponents. If it's negative exponents, I got to send it uptown or downtown. Okay. I also see these guys here. I've got this 10 and this 12. Okay, so I cover up the variables and I say, okay, what's 10 divided by 12? That's just a fraction. What's 10/12 reduced? I want to reduce that if I can. Arr, for you pirates out there. What's 10/12 reduced? Will, what do you get? What's 10/12? 5/6 reduced by 2. We get 5/6. If you're bad with fractions, take 10 divided by 12. Press enter, math frac. We get 5/6. So far, so good? All right, this t stays right there. The problem is I got this s. That guy's a negative s exponent. I got s to the negative second. We want to make that positive. So I shoot it downtown. So we end up with 5/6t s squared. Or if you prefer to write it 5/6 s squared t, you can do that as well. Either one of those I would accept. Either one. We only move the negative exponents. Okay? You guys good with that? All right. So we take a look at the next one. I've got 10x to the negative third. The 10 doesn't reduce at all. Think of this as over 1. Only thing that moves is this guy right here. I end up with 10 on top and x cubed on the bottom. So final answer. 10 and then x cubed. All right, we got a couple more left. I've got negative 3 raised to the negative 2 power. Take that whole thing, because it's a negative 2, I'm going to send this guy downtown. So now I got left with just 1 on top. So we have a kind of a placeholder. And then I have negative 3 and then make it squared. So this is a little bit different than number 5. I'm actually taking the negative 3 and squaring it. So what's negative 3 times negative 3, or what's negative squared? What's a negative times a negative, or a negative squared? What do you get, Colt? Or are you just stretching? Yeah, 2 negatives make a plus. Very good. When I take a negative and square it, you should always get a positive. Okay? If you're not using parentheses, then you would get a negative 1/9. So make sure you put parentheses around that denominator. You guys okay with that? All right, number 10. As I take a look, I've got 4 to the negative second, h to the negative fourth, and j cubed. Who moves? Who goes downtown? What do we got? Who's moving? Kelly, who's moving here? Number 10. Who's got negative exponents? Yeah, these guys get down there, right? So I'm left with j cubed on top, j to the third power. It's called j cubed. And on the bottom, the 4 is now squared. And h to the negative 4th is now h to the 4th. If you leave it like that, I'd probably circle and take off half a point because I want you to simplify. And the last thing I should do is take that 4 and square it. 4 squared, 4 times 4 is how much? 16, and then h to the 4th. How are we doing? Not too bad. So again, negative exponents. Let's finish up 11 and 12 before we get out of here, gang. So as I take a look, we got a lot of stuff going on. First thing I notice is h to the 0. What's h to the 0? H to the 0 is just 1, right? So I don't even need to worry about that guy. But we got some uptown, downtown stuff going on. So I take a look, the 10f stays, but this g to the negative 5th comes down, and this h to the negative 2nd comes up. So h to the negative 2nd is now uptown, and that g to the negative 5th is now down, making it a positive 5. So that's the big idea out of today, guys. Is uptown, downtown. If it's a negative exponent and it's uptown, send it downtown. If it's downtown and it's negative, I send it uptown. Last but not least, before you do number 12, before you leave, what is anything raised to the 0 power? Even all this. That is 1. Okay? So final answer for 12. All right, so now we're going to evaluate. So if I look at 13, 14, 15, and 16, it says evaluate each expression, and they're giving us values for x, y, and z. So x is negative 2, y is 4, and z is 2. So all we're going to do is pluggy chuggy and see what we get. As I take a look at number 13, we got 4, and then x to the negative 1st power. Well, we want to plug in x. What's x? What is that? That's negative 2. All right. We got pens and pencils. You, Gail, come on, man. You're tardy. You have a pencil. Oh, man. You got nice shoes, though. Cold. We got some of this done. We didn't get all. I said we didn't get all done. You do the front page of your worksheet, and we didn't get it all done. You know? So if you got it all done, you're ahead of the game. Okay. So we go ahead and take this 4, and we plug in that negative 2 to the negative 1 power, and we do a little simplifying, right? So I get 4, and now this negative 2 I can send downtown. So negative 2 to the negative 1st power is now negative 2 on the bottom. To the positive 1st power, just negative 2. Does that make sense? So it was uptown, I sent it downtown, and now the exponent's a positive 1, or you don't even need to write it if it's an exponent of 1. We go ahead and simplify. What's 4 divided by negative 2? What do you guys get with that? 4 divided by negative 2? Negative 2. Bam. Okay, so final answer is negative 2. All right, so I take a look at the next one. I got z to the negative 3rd power. So as I take a look, I have z to the negative 3rd. If I look at z, z is 2 here. Yeah. So go ahead and plug that in. Again, now we have a negative exponent. So what do we do with that negative exponent? What do we do with that 2? What do we do with the 2? Cool. Move it uptown or downtown? It's uptown right now, so move it downtown. So we're going to send this guy down. So what we have here is 1 over 2 to the 3rd power. And we should know what 2 cubed is. What's 2 times 2 times 2? It's 8. 2 times 2 is 4, times 2 is 8, so we get 1 over 8. Our final answer. How are we doing, y'all? Again, we don't have to do all of these, but we'll do a lot of them. Let's do at least one more. So if I look at 15, I have the opposite of x to the negative second power. Okay, so the idea is this is the opposite of what I'm inputting to the negative second. Well, I'm going to put this x, which is negative 2, right in here. You guys okay with that? So far, so good? Well, here's the idea. This negative is, no, this negative has to follow a little rule we talk about. You guys remember this guy? Please excuse my dear Aunt Sally. Get it so you can see. Please excuse my dear Aunt Sally. You guys heard that before, right? I don't have an Aunt Sally, I have an Aunt Susie. And Aunt Susie says I got to take care of my parentheses and exponents first, right? So I've got to move this negative 2 first, okay? So I got to take care of this guy and simplify and send that guy downtown. So this negative is staying up top. I'm going to leave that as a negative 1, okay? And now negative 2 to the negative second power is negative 2 squared. Any questions what I did so far? So I moved that guy that was uptown with a negative exponent. Now I shot it downtown. I do a little simplifying. Negative 1 stays on top. And what's negative 2 squared? What's negative 2 times negative 2? You're getting the 4 symbol here, Ivan. Good job. So I end up with negative 1/4. Okay. You guys have any questions with that? One thing that you guys should know is if I have a negative number and I raise it to an even power, it now becomes positive. If I have a negative number and I raise it to an odd power, like 3 or 5 or 7, now that's still negative. Okay. All right. Questions? Yes? No?
When you bring the 2 exponent down, is that supposed to be a negative 2 exponent under the 1?
Right here?
Yeah.
So when I bring it down, the reason why we brought it down is so that we make it a positive exponent. So it was negative 2 on the what I call uptown or in the numerator. When I send it down, it becomes positive.
And wouldn't that become negative 4?
This guy?
Yeah, the negative 2.
So negative 2 squared is negative 2 times negative 2, and a negative times a negative makes that positive. Yep. Good question. No, it's right. So I end up with the negative 1. The negative stays on top, and then negative 2 squared becomes positive 4. Okay. So good question. All right. Let's take a look at 17 here. When we look at 17, 17 says the population of a suburb is 4,000 people. The population of the suburb is expected to double each decade. Oh, man. So the expression follows this, 4,000 times 2 to the d power. And it models the population of the suburb after each decade d. It asks you to evaluate the expression for d equals negative 2 and d equals 1. So there's 2 things I got to do. So describe what each value of the expression represents in the situation. So as I take a look, I've got 4,000 and then times 2 to the d power. All right. So in this case, I'm going to do this one first, where d is negative 2, and I'm just going to plug that guy in right here. All right, so I've got 4,000 times 2 to the negative second. Bless you. So I do a little simplifying, right? I got a negative power. I got to take care of that negative exponent. And how do I take care? What do I do? How do I make this a positive exponent? Where do I send it? Damien? Yeah, send it down. So I still have 4,000 on top, but on the bottom I send this guy down, and now I have 2 squared, right? A negative exponent now becomes positive. So I simplify that a little bit. You guys can probably do this in your head. We know 2 squared, 2 times 2 is 4. And what's 4,000 divided by 4? And that equals 1,000 people, right? All right. Good stuff. So if I do the other one, I'll do this one in blue and orange here. I'm going to use that same formula. So I've got 4,000 and then times 2d, where d is again decade. And I want to see what happens after 1 decade. So I'm going to do d equals 1 here. Pluggy chuggy, simplify. What's 2 to the first? That's just 2. And then 4,000 times 2 is 8,000, right? We get 8,000 people. So again, big idea is we're looking to evaluate this guy. The D value, again, is our decade. So after 1 decade, I started at 4,000. Now after 1 decade, I'm up to 8,000 people. If the decade value is negative, that's going backwards, right? So this city, 1 decade before is half of that 4,000, which would be 2,000. And then half of that would be 1,000. So that's how we get that. So that's what that D value represents. Okay, if the D value is negative, that was in the past. If the D value is positive, that's in the future, what's going to happen if it's doubling every time. Okay. All right, ladies and gents, I've got a few that I want you to try here. I want you to try the odds. So take a second and go through the odds. So as I take a look, shoot it downtown. Woo! I got 1 over 13 here. 113. You can think of that as 13 to the 1 power, but with 13 to the 1 is just 13, so you don't need to write the little 1. It's not necessary. Okay? So I'm skipping over 2. If you want me to do it, we can, but I'm looking at number 3. What's 11 to the 0 power? 1, right? Is that what you're going to say, Audrey? You get 1. Perfect. All right, now I take a look at the next one. I have the opposite of 15p all raised to the 0. So cover up that guy and do 15p to the 0. What's 15p to the 0 power? That's just 1, right? So the opposite of that would be negative 1. Okay. So again, we got to do exponents first, and then we take care of multiplication. All right. So I take a look at the next one. No negative exponents. So something's moving. Ivan, what's moving? The x on number 7 is moving down, right? So I have 4. On the bottom, I have an x cubed. On the next thing is I got y to the 0. What's y to the 0? That's 1, right? So it's almost like it's not there because 4 times 1 is just 4. You can just cross that guy out. It's just 1. Okay, so if you wrote it as 4 times 1 x cubed, you'd want to simplify that. Okay, questions with that one? So you look at each one individually. All right, we take a look at number 9. Number 9, I have in the quantity, I have negative y raised to the negative 3rd power. In this case, I have x and y and z. There's negative 2, 4, and 2. So I'm going to go ahead and plug this guy in for y. So if I plug that in, that's negative 4, and then to the negative 3rd power. No negative exponents. So what do I need to do? Shoot it downtown. So I take this whole thing, -4, and I bring it down and make it a +3. So now what happens when you take a negative and you cube it? What happens when you take a negative times a negative times a negative? You get a negative, right? And then what's 4 times 4 times 4? 40. 4 times 4? 16 times 4? 64. We should get -64 there. Okay. Quiz or test, we want to see a little bit of work. Don't just tell me the answer without showing a little work. All right. Any questions, y'all? So as I take a look at number 11, I asked you to do all the yet, so let's look at number 11 before we let you finish up with homework and ask questions with that. It says a population of birds doubles every 8 years. So the expression is this guy, 6,400 times 2 to the t, which models a population of 6,400 birds after t periods of 8 years. So he says evaluate this where t is 0 and where t is -2 and describe what each value of the expression represents. So as I take a look, I take my expression here, and all I did do is plug it in. I've got 6,400 times 2 to what power? To the 0 power. What's 2 to the 0? That's 1. So that's 6,400 times 1, which is just 6,400. And then where are we talking about? Birds? Okay. So what does that represent when t is 0? When time is 0, what does that represent? Colton, what do you think? Like, yeah, the starting point, right? We started at 6,400 birds, and when time is 0, that's where we started, and then it starts growing from there, right? Or if our t value is negative, then it starts going backwards, right? This was like 2 years ago, or 2 8-year periods ago. So when I look at this one, 6,400 birds times 2 to the -2nd power. We got to shoot this guy downtown. So I've got 6,400 and then divided by what? Divided by what? What goes on the bottom? Dan? 2. And what do we got to do with that power?
2.
Make it positive. Very good. And we should know what 2 squared is, right? What's 2 squared, y'all? 4. This is easy, Mr. Gotsch. And then we take 6,400 in our calculators and divide by 4. We just do our heads. What is 6,400 divided by 4? What's 64 divided by 4 and add zeros? What do you get, Danny? Boy, 1,600. Okay, so again, that represents 2 periods of 8 years ago. So 16 years ago, there was 1,600 birds for this population. Okay, so good stuff.